Or you may just be overwhelmed by the workload. People remember a program called Candid Camera? One of the most memorable ones for me was the person who was in the donut filling factory, or the donut factory had the gun with the jam, and you inject the needle into and you did this by hand. And what they did is they had somebody set up with the conveyor with the donuts coming past, and they had to inject each one as it came past. And what they did is just sped it up and faster and faster and faster. And then what happens, and it's actually what happens in systems as well, is that the person started worrying about the ones that were falling on the ground. So stopped injecting the jam at that point to pick up the ones that were falling on the ground. And actually that's something that happens very often in systems. When you get a workload peak, maybe a call center, and there's a television advert goes out. Actually, with satellite, it's not so often that happens. But when we used to have these shared experiences of watching one TV channel, maybe for a game, a big football game or something, there'll be a timeout, and everyone reaches for something, wants to phone up their credit card company at that moment, and what happens is the system is inundated with calls, and actually the result is that nothing happens. So this sort of software failure is what actually leads to downtime. So there it is, the IEEE, no less. Okay, a formal definition of availability is the mean time between failure divided by the mean time between failure plus the mean time to repair. You will be tested on this afterwards, so if you want accreditation, just make sure you know these terms. What does that actually mean in real numbers? About a decade ago, I think Sun had a thing where we talked about a thing called web tone. Anyone remember that? And there was a debate about whether you needed 4 nines or 5 nines. What does 5 nines actually mean? It means that in a year, you can have 5 1/4 minutes of downtime. Sorry? Yeah, which means you're not running Windows, as says our friend here. Of course, the further you come, the more nines you have, the more it costs. And the world of project planning has given us this lovely truism that you can have something good, cheap, or fast, and you can pick any two. And if there's one thing I'd like you to take away from this room today is good, cheap, and fast, and you can have any two. Because there are a number of people who just don't seem to get it. Go round the exhibitors there, and you will see combinations of good, cheap, and fast, but you'll only see 2 at a time. Okay? I'll test you on that one later as well. In terms of availability, then I would say this is, good is highly available, cheap is low cost, of course, and fast, we're looking for, performance in a metric that is meaningful to you. And having spent many years as a performance engineer within Sun and doing consultancy and so on, performance, very important that the metric of performance that you're buying is the one that you want. So it's important that you know the difference between bandwidth and IOs per second. It's important that you know the difference between a homogeneous workload and a heterogeneous workload. Is it going to be mixed read and write? Is it going to be mixed block sizes? Is it going to be mixed sequential and random? And what matters to you? And it's important that you understand those terms when it comes to performance. So when we talk about good, cheap, and fast, it'll mean different things to different people. And the danger is that you'll have a one-size-fits-all. I'll just go and buy SATA drives because they're cheap. I'll use an Exenter because that's got ZFS and that's brilliant, and it'll save me from all the ills of SATA. And I'll do RAID Z3 across 50 drives. So that'll be good and cheap and fast, won't it? Oh, because I can put some SSDs in too. No, it's not one size fits all. And that's why companies like ours are around, to try and keep you honest, but also to save you from yourselves. I have various views of technology. One view is that Unix is like Lego, that I have all these little bits and pieces that I can plug together in different... with Lego, you can buy the set, you have the diagram, the blueprint, and you can build what's on the box, or you use the pieces and you do something innovative for yourself. I think sometimes a better analogy is a piece of rope, and there's plenty of rope, and you can go hang yourself. And so what we're trying to do here is to say, yes, there's all this wonderful stuff, but keep it simple, stupid, and know what are the metrics that matter to you. Don't just buy one of those because he got one and he got away with it. Think about it, think it through. Keep it simple, stupid, and think it through. Okay, perhaps a better metric, and one that you need to think about, is what your users are expecting, because that strict definition of availability in nines, this is more meaningful in terms of service level agreements. So 5 nines is great, but it might be utterly meaningless to your users. What they're thinking is that, between the hours of 8 a.m. and 4 p.m., they want the system to respond with a 2-second response time, maximum response time, say in the 95th percentile, and they don't expect to lose any transactions or to suffer any downtime during that period. That may be what they're working to. But that actually leaves you with 16 hours of additional time to do other stuff. So a 5 nines thing may not be that applicable. But then, of course, you may be a global company like us and need that 5 nines capability. Okay, let's look at some of the issues around high availability. And the first one that we talk about is a single point of failure, or a SPOF. And so this is just a little exercise again for you to wake up, have some sweets if you need the blood sugar. Can you spot the single point of failure? Well, it may be this guy, it may be the human factor actually, that's the... Okay, can you spot single points of failure? This is some sort of network. This is a server, this is a disk subsystem, and these are client devices. Single points of failure in this environment? Single connections to the network, yeah. Single attached to the array. Single array. Single, yeah, single head, lots of single things. Okay, so does the term belt and braces translate here? It does, no, because it's suspenders and belt. Belt and suspenders, well, you see, in the UK we wouldn't get away with that. Suspenders means something else. But one of the things, the other thing other than the good, cheap, fast thing I want you to take away, pick any two, is that you should be designing your systems to fail. I'd say that again. Design your systems to fail. If you think your system is not going to fail, then you are mistaken. So you need to design your systems to fail in such a way that when they fail, it has no impact at all on your business. So design them to fail, but in such a way that it has no impact. So belt and braces. Now this is an improvement on the previous architecture. It relies, though, on the client to do everything twice, and for the client to cope with failure. So this system is now tolerant of any single point of failure, and it's actually tolerant of more than one point of failure as long as it's on the left or the right. There's actually a lot to be said for this as an architecture. It's something that would be used in aircraft flight systems. It's something that people get religious, don't they, about the processor they use and the vendor they use. But I'd encourage you to think, if you're really serious about high availability, have one stack which is, say, Solaris Oracle running on Spark, and have another stack that is Intel, Linux, with MySQL, and have them so that you have no common architecture between the two. So the sort of generic problems that crop up in the Intel instruction set or the Spark instruction set won't bite you at the same time in both sides of the implement. There's a lot to be said for that. So, autopilots tend to have 3 systems that are written by different groups of people and which take a vote on which action to take once they have. This is where this is getting serious. You can see that good, cheap, and fast, pick any two, can apply very quickly here. But what we would say is, well, are you serious about high availability or not? If you just want cheap, then the door is at the back, and it's been nice to have you with us. But high availability is not cheap. Can we just set that expectation now? Okay. If we think of cloud computing, RSF1 actually plays very nicely in the cloud, managing middleware and the LAMP stack, all sorts of stuff that might happen in the cloud. RSF1 is managing today. So we could have 2 clouds from, say, 2 different vendors, and we could have failover between those. That's certainly good, but what we're going to be focusing on more today is this, where we have at least two nodes with common storage and mirrored. I'm going to say mirrored. I'm still a little bit agnostic about this, but the more I think about it and the more I read ZFS Discuss, the more I think I want to do mirroring and not Z3 or Z2, and certainly not Z. Does that shock some of you? But again, this is about high availability. It's about good, cheap, fast, pick any two. And RAID Z3 may be cheap, but it's not fast, and it's one of the issues at the moment that it faces is unbound resilver times. And unbound resilver times do not jive with high availability. So although RAID Z3 is attractive in many ways, in a highly available system, we don't recommend that. So let's just talk a little bit through the cluster that we have here at the bottom. So we've got the shared storage. Now this could be fiber channel, it could be SAS, it could be iSCSI, if you must. It could be ATA over Ethernet, Co-RAID, company that we've done some work with, very impressive. I was utterly, I dismissed it, didn't I, Grenville? And we did some work with them and we improved their performance, and it's an interesting option. But multiple attach points, mirroring, we'll take that as something. But RSF, the 2 nodes are talking to each other with a heartbeat. And that heartbeat could be a serial connection, or it could be a network connection using UDP. And when you've got shared storage, it can be disks. Now, the heartbeat is not quite the same as the heartbeats that you find in other clustering technologies. The heartbeat in RSF1 contains state for the entire cluster. It contains state about how the cluster is configured and state of what each service is doing at any point in time.